And I'm live. That is cool. Today is 10th of September 2025, Wednesday. And yesterday was a contest in which I was able to do two questions in the first, I guess, 15 minutes. But then I was just unable to do the third question. And before moving on to solving the CP31 sheet, first I will go through my solutions for yesterday's questions, the first question and the second question, and also we will read the editorial to see how we can solve the third question. So with that, we can simply begin. No more overheads. Okay, code forces. Yep. And yep, here are some of my solutions, contests. And one more funny thing, there was a contest on 8th of August, 8th of September, one day ago. This one, 1048, and in that contest, it was supposed to be rated, but in problem D, unfortunately, it was discovered only now that the statement was missing an important condition. The correct statement should include the line, the operation 2 can only be applied at most once. The statement will be corrected soon. And we believe this issue affected many participants of this round, and therefore we have declared this round unrated. We sincerely apologize for this mistake. Okay, let's see what happened. If you go to their announcement, this guy who wrote the article announcing hello code forces, let's see, minus. It is very, very disliked now, I guess. And just because this guy wrote this article, look at his contribution now. Minus 125. He lost everything that he built up to this point, and now you you cannot recover from this point. Minus 125, and if this were on the with the opposite sign on the opposite side of 0, this would be one of the top contributions. But he's now, I guess this might just be the least contributed person now, the person with the least contributions on code forces. That is very sad. And now for yesterday's contest, this one, 1049. Hello. It was so yes, okay, let me tell you my intuition. First I thought shit. When I read this problem statement, it was like shit, what can I do? But then I thought shit, okay, but then I thought that if I do sort this, wait, that is a very bold line. If I do sort this whole thing, initially we have some zeros, 1 0, some stuff like that. But if I do sort this whole thing, then I should get 1 1 1 1 0 0 0 0. At least in this case, I should get something like this, and all my ones should be in this position, the last position. So there is this 0 in this range, which has to be 1. There is also this 0 in this range, and these zeros need to go out. So how many zeros can I take away from this range, which needs to be all 1 in one operation? In one operation, let's say I choose one of these zeros. I mean, I have to choose one of these zeros which is inside this range to make this 0 go away, and I also have to choose one of these ones which are outside the range, and I have to choose another third index. So I might choose uh, the third index in middle. It might be in this range, which is a 1, and if it is a 1, this 1 will take its place, and this one will go and fill up the 0 place, and I have fixed 1 0. But if I were to choose something outside of my range, Like if there was a 1 here and I chose this one and I chose this 0 to replace and I chose this 0 as the index in the middle, then there is no point. Like, what is the point? And I think we can rotate this in any direction we want, right or left shift. Yes. In this case, we shift this whole thing into left, and this one will take this zero's place and we will fix 1 0. So the point is that in one operation, I can only fix one of these zeros, which are not supposed to be in this range, and that is the answer, the number of zeros in the range where ones should be. Hello, bro, you still have enough time for rating for the good morning. Hello. Hey, I don't understand the problem, but I guess you are having difficulties with division 4. I guess you just have to uh, practice. Yep, this is from yesterday's contest, and yeah. So the answer is just the number of zeros which are there in this range, which is supposed to have all ones when this is in sorted order. So for my solution, I did this count the total number of ones from beginning to the end. And this is not the original code. I revised this today in the morning. The code that I submitted yesterday was 15 hours ago, was this one. I was like, I wrote a single loop and went through the whole string and I counted the number of ones, and then result is going to be when I start from this range n minus 1s. N minus 1 is the first number which is supposed to be 1, and all the numbers after that are all the characters after this are supposed to be 1. So if I see in this range any 0, I will have to fix it and I will increment my response by 1. But instead of writing two loops, I could have simply done this. Call the count function, count s dot begin, s dot end, count the number of ones in this range, and in response we are just counting the number of zeros. So int res equals count s dot not begin, s dot end minus the number of ones, because if there is 1 we will go, if we subtract 1 from end, s dot end, we will go to the last index because end is 1 past the last index, and from this index we will go till end and count the number of zeros, and that is our answer. Yep, that is the correct answer. So yeah, it took some thinking, but it was doable. Yep, I did this yesterday and then I submitted again with this version of the code where I'm using count instead of a loop. And then for the next question, question number B, my son, how long did you take on this problem? I guess 6 minutes. Yeah, 6 minutes. Contest began at 20:05:05 and I submitted this at 11, so 6 minutes, and then it took me 7 minutes to do the second question, but then it took me 1 hour 2 minutes and I tried to submit the third one, and then again and again and again, but I was never able to get this one right. First I got it wrong on pre-test 2, then on 3 3 3 3 3 3 3 3. Yeah, it was bad. And now for question number this one was pretty cool. This one was pretty cool because this was very similar to a question which I saw in a earlier context contest, what the heck, contest. So here we have a number x which is below 10 power 8, and then we have to give another number y such that if I have x, one number, and I have to return a number y, and I will attach them like so. If x is 1 2 3 and y is 2 3 4, by attaching them, concatenating them, I will get 1 2 3 2 3 4 as my new number, and this y has to be such that this concatenation of x and y should be divisible by x plus y. So that is the nature of this y number, and this concatenation, you can write this in a arithmetic form. Let's say x is your number and the number of digits in x is d. And if you multiply x by 10 power d plus 1, this is equivalent to concatenation, to this concatenation, because you shift x to the left by multiplying it by 10 raised to the power of number of digits, and then you add y to it, which is just mathematically equivalent to this thing. And I thought it would only make sense if I make this y some factor of this x. So I thought if I chose this y equal to some constant number multiplied by x, then this equation would become something like x into 10 to the power t plus c into x. And if I take x common, I will get c plus 10 to the power d. And since I want this to be divisible by x plus cx is ry, we would get x into c plus, this is plus 10 power d divided by x c plus 1, x divisible by x. So what we need is a certain c divided by c plus 1. And if you think about this, if I thought let's take c equal to 1. If c is 1, what we will get is 10 something, 10 power something d plus 1. And in the bottom we will get 2, 1 plus 1, 1 plus 1 2, but this number is odd, so this is not going to be divisible by 2. If we take c equals 2, we will get 10, a bunch of zeros and then a 2, because c is 2, and dot 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 for a bunch of zeros, and at the bottom we will have 2 plus 1 3. And we can see that this number is always divisible by 3, because we know the rule. That is, if you add all the individual bits in a number, all the individual digits in a number, and whatever the sum is, in this case, the sum is going to be 1 plus 2, which is 3. And if this sum of digits is divisible by 3, then the whole number is also divisible by 3. So when we take c equals 2, we have our answer, and our answer y is going to be 2 into x. And this was like the code that I wrote for this. I thought this is wrong. This has to be wrong, because this was very simple. Take in n and return 2 multiplied by n. And that is actually the correct answer. If you go to the tutorial, you will see that. Positive or negative delta? Huh? In what do you mean by delta? In oh yeah, shit. Okay, yes. Positive, 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 positive. Delta by my rating change. I guess it is positive 50 or something. And if you go to the tutorial in the code, this is the exact same code. Take an x and multiply it by 2 and return 2x is the answer. That is crazy simple. But then now comes the third question, which I was unable to solve, even though they say that it is 1200 rated. And I don't know which concepts are at play here, but in this one, I was able to figure out a lot in this question. And wait a minute, I will be like right back in a minute. Just a minute. We are, yep. I'm totally back, and yes, I was getting a call from Home Minister. Yeah, so yeah, this third question, I was able to figure out some stuff in this, and this thing which says that at max they can play 10 power 100 turns. And this is so off leading because I figured out that you do not have to play Bob for Bob, the second player. The best choice is to just stop the game. They have two options, either to end the game for both the players or to choose or to make a move. And to explain this question, they have an array. Let's go with this one. They have an array like this, and in this array there is a function fx. That is too small. They have a function, and this function takes in the array, let's say a, and this returns just this thing which they say in the question itself, this thing. This is what this function returns. It takes the first number, adds it, second number is subtracted, then added, then subtract, then add, and then subtract. And yep, so this is what this function returns, and this cost value at the start is 0. And Alice and Bob are two players, and both of them have two options, either to stop the whole game, right? They just end the game, or to choose two indexes I and j, and the numbers at I and j, let's say this is I and this is j, these numbers will be swapped, and whatever is the value of I minus j, absolute value, that will be added to the cost. So let's say Alice does something. Alice makes a move and increases the cost. So what is guaranteed is that whatever operation, if they do this IJ operation and not stop the game, whatever operation they do, the cost is going to go up. So let's say Alice makes a move and does not stop the game. And whatever move Bob makes, let's say he swaps some value so that the value of this function, and yes, Alice, what, wait, is my camera fine? No, shit, my camera is not fine. Okay, something bad is happening with my camera. That is very trippy. Wait. Let me try to fix it. Uh, like we could consider in case such case infinity. No, shit, yep, it is bad. It is bad. Shit, faceless YouTuber. Let me just stop my camera and work like this. Studying is the more important part. So we have this, right? Alice wants to increase the cost, and Bob wants to decrease not the cost but this whole function, and Alice also wants to decrease this whole function fx. Now, if Bob makes any move and does not stop the game, then the cost is going to be increased. Cost is will be increased, and whatever move Bob makes to swap, let's say Bob takes some big positive number, and puts it at a place of negative number and brings a small negative number into a positive number. So the overall fx value will decrease. But then Alice can make the same swap and bring back that big positive number and make that small number negative again. And during this whole interaction, the like this the product this function, this term does not change, but this cost has increased. So for Bob, the best choice always is to just stop the game. No matter what Alice does, for Bob, the best choice is always to just stop the game. So Alice gets the first move, and in that move, she has to decide either to stop the game right now or to make a choice. So she will find the best I and J to make the best swap so that she can increase this function as good as she can. And I went down a lot of different ways of finding this thing. Like, this is what I wrote. This does not work. This only works for a few cases like this. It works here, but it gives wrong answer in pre-test 3 and stuff. So this is not really correct. And now my goal is to just read the editorial and try to understand what they raise. What do they mean by this? This part. So note that if Bob chooses two indices L and R on his turn, then Alice can also choose the same indices L and R on her next turn, and this will increase the value of FA ultimately. Yep, because this increases the cost. So it remains optimal for Bob to end the game on his turn, right? That is something that we agree with. So right now, in the first place, when Alice gets a fresh vector like this, she has two options because we know that Bob will stop the game. So she has two options, either to make a move, to make a swap, or to just stop the game. And she will make, so all we have to do is find the most optimal swapping positions or no swap at all. So now there are two possibilities. Alice can end the game on her first turn, and Alice can choose or should be or Alice can choose two indices and Bob ends the game. Now first case, finding FA is trivial. When Alice ends the game, FA is trivial because there is no change, cost is 0. Thus we are left to find the maximum value of FA that Alice can attain on her first turn by choosing two indices. Yes, the maximum value that Alice can attain by making a swap. There are only two types of swaps between even index values and odd index values. We swap even with even or odd with odd. In this case, the only thing that we are getting is the difference between their indexes. In this case, only cost increased by difference in index. So if we go with this thing, okay, what is that? If you go with this thing, this is what Alice shit. This is what Alice has. And here we can write the signs, right? This is positive, this is negative, this is positive, this is negative, this is positive, and this is negative. And their indices are 1, 2, 3, 4, 5, and 6. And there are two types of swaps here. First of all, blue ones. Okay, no, not blue one. We are representing them with blue. Blue ones where we swap numbers with the same sign. And if I swap a number with the same sign, then the sign of that number is not going to change. So positive numbers remain positive and negative numbers remain negative. Therefore, the overall effect is only going to be this function. This function, since this function has two parts, this part is going to be exactly the same thing because positive numbers are still positive and negative numbers are still negative. So this part is going to be as it is, but this part, the cost is going to increase. And since we are looking for the maximum value to maximize this thing, because Alice is making the move, then we would like to If we are swapping positive numbers, then we would like to swap positive numbers which have the maximum number of elements between them. So here the index is 5, here the index is 1, 5 minus 1, that is 4. That does not look like a 4, but this is 4. And that is by how much our cost will be incremented by. And since our series begins with a positive number, so if the last number is negative, it would only be negative if n is even. But if n is odd, then the last number is going to be positive, and we can swap the first positive number with the last number. And since the last number's index is n and the first number's index is 1, then if we make this swap of positive and positive, we will get n minus 1. N minus 1 if n is positive. If n is positive, if n is odd. So if n odd, this is and, bitwise and of n with 1. If n is odd, then the maximum cost of making swap of same signs is n minus 1. If that is not the case, if n is even, like in this case n is 6, then I will swap this first element with this second last element, and second last element is at index n minus 1. And from that I will subtract the first element, index of the first element, which is minus 1. So the value would be n minus 2. Here n minus 2, that is the maximum value that we can get. And you can see this even works when we have only 2 elements, because when we have only 2 elements, this thing is 2 and 2 is even, and we will get 2 minus 2 from our formula here, and this would be equal to 0. Cool, because there is only a single element with positive sign and a single element with the negative sign, so we cannot make swaps of this kind where we are swapping elements with the same sign. So that is one kind of swap that we can make. Another kind of swap is copy paste, fast, is this one. Let's write the whole thing again. Nope, red color. This positive, negative, positive, negative, positive, and negative, and their indices also 1, 2, 3, 4, 5, and 6. And here we can also swap elements of different sign or different signs. So +1, some positive number, let's say AI, with some negative number AJ. And the way that I went about doing this, I found the best negative number to swap with, the best positive number to swap with, and then whenever I see a negative number, I'm taking the best possible swap. If I were to swap it with a positive number, and the best possible swap, the best increase that I would get, if I were swapping this current negative number with the best negative number. And since this is a negative number, if this number's contribution is like not as good, not if this current number's contribution is better than the best possible till now, I update the best possible number. And this this just somehow doesn't work. It looks good, but I don't know why this was not working in the third test case. Wait, shit, if well, I can now see the test case. That would be cool. A nice insight. Hello. I guess I'm 21. And shit, my camera is broken. Yep, my camera is broken, and if it is totally broken, doesn't work. Okay, I'll fix it later. And here, let me submit this again because now contest has ended and I would be able to see on which what was the exact test case in which I got the wrong answer. Yep, wrong answer. On 112th, expected 7, found 6. Why would something like that happen? I don't know. I cannot even see the test case. Anyways, my approach was wrong somehow. And what they suggest in the editorial is that I can generalize this formula and I do not fix that I is always smaller than less than j. And I use some kind of prefix minimum over odd and even indices. I don't know what prefix minimum is. I know about prefix sum, but I don't know about prefix minimum. So that is something that we will have to see. And yep, so let's actually see the code. Vector, we take in n, then we take in all the values. Yep, cool, makes sense. And then the answer, we are going from start till the end. Okay, this part is calculating this part of our function fa. And now we have to see the maximum cost, how much we can change this ans thing. And we are saying this initial value is going to be equal to ans answer. And for we are going through all the elements and answer is maximum of answer and init plus I minus I modulus 2. That, what is that? Init is initially answer and we are adding I to that number and we are subtracting 2, which is okay, which is logically similar to this thing that we were doing here. This thing, it is logically similar to this thing. Why, you might ask? Because we have written this: if n is odd, if n is odd, then we will take n minus 1. Else, if n is not odd, then we will take n minus 2. And here our n is they didn't have to go through all of this trouble, and this thing would actually be equal to this. There is a closed formula for this, for finding this exact same thing, because they are going through I, and whenever I is odd, right, whenever I is odd, they are subtracting 1, and whenever I is even, they are not subtracting anything. And since n starts from 1, 3, 4, 5, 6, and I starts from 0, 2, 3, 4, 5. This thing is positive. In both the cases, this is negative, positive, negative, positive, negative. And here we see that whenever I is even, we have a positive number, and whenever I is odd, we have a negative number. And from our formula, we see from this formula, if n is odd, by this we are checking if n is odd or not. And whenever n is odd, we do n minus 1, n minus 1. And here, let's say n is odd here, and n minus 1 would be equal to 2. And in this case also, when n is odd, when n is odd, I is going to be even. You can see I is 2 here, and whenever n is odd, I is 2, because I equals n minus 1. I literally equals n minus 1. Then we have the correct answer n minus 1. And whenever I is odd, whenever I is odd, n is even. And when n is even, the answer is I minus 2, n minus 2. And we have I equals n minus 1. If we subtract 1 from both the sides, we will have I minus 1 equals n minus 2. N minus 2 is what answer we proposed, and I minus 1 is what they have, because I is odd. In that case, when n is even, we are subtracting 1. Remainder, I remainder 2, I modulus 2. And since I is odd, modulus 2 is going to give 1. And this thing just means I minus 1. And I hope. And yep. And something bad. My internet is down. My internet is down. My internet is bad. What the heck? Wait. Wait, this messed up. This is messed up. This is messed up. Okay, it is fine. Now it is working. It is working. Hmm. I hope it is working. Is it, am I visible? Am I audible? If anyone is there, is this fine? Please tell me. That would be pretty nice of you. And from my OBs, I see now it is fine. Now it should be fine. I hope. I hope it should be fine now. I mean, two people are supposedly watching. If you could just tell me if this is working or not. And latency is also low. Yeah, I guess latency is high right now. And from my side, it seems okay. Even though my camera is not working, it seems okay, just okay. And camera is back up. That's cool. That is cool, pretty cool. And my phone is also charging. And yeah, it seems fine. It seems fine. And I will just begin. Like, I'll just continue. So this part, this could have been a closed form formula, but anyways, this is also fine. And then LL minimum even. Okay, they are doing some kind of thing which I do not understand here. Let's see what they are trying to do. Minimum even is long max. Long max, something that they have not defined. Okay, long max, it is the maximum long value. Minimum even is going to be long max divided by 2, and minimum odd is going to be long max divided by 2. And then we are going through the whole thing, and whenever I remainder with 1, whenever I is odd, I just forgot that people use modulus sign to check if a number is odd or even. So if I is odd, then the current number should be negative, and answer is maximum of init plus I. Why they are taking maximum of init? Okay, anyways, maximum of init plus I plus AI minus minimum even, or answer. and maximum odd is this, and answer is changing, and minimum odd and maximum even. Minimum odd will become negative, is minimum I minus AI minus AI. And hopefully the video is fine now. Hopefully the stream is fine. I hope. There have been a lot of errors, but now I hope it is working fine. And what is this thing? What is this thing? So they found initial answer in it, which is answer, the already present answer, whatever it is, or this value, answer plus this thing. And this thing, this is equivalent to something like, this is equivalent to long in it equals res plus if n is odd. If n is odd, then n minus 1, comma, n minus 2. If n is even, right? Yep. So this is equivalent to this thing. And then they have minimum, wait. Okay, my camera is messed up. My camera is just messed up. It is not working. My bad. My bad. Today there are just bad things happening. So LL minimum even, that is something. And then log, the maximum possible value for a long divided by 2, which is equal to minimum even, and maximum odd has the same value. And then we are iterating through all the elements. And what are we doing here? If the current element is a negative number, if the current, okay, this makes sense. This makes sense. This is what I also wounded up figuring out, that since this current number is odd, is at odd index, this is going to be negative. And if I do replace this current number with something, whatever that something is, then first of all, I will be adding this number to my answer, because this will no longer be negative, and removing a negative number is equivalent to adding its absolute value. And then since this number would be going to a place which is positive, therefore I will be adding it again. So in total, I will be adding this current number twice. Then we have init plus I. Why do we have that? Init plus I minus minimum even. And we are also updating the minimum even. Minimum even will be equal to minimum even. And initially we have them like maxed out. That would make sense. Minimum even would be equal to, this is what I gain, this is what I lose. Shit makes sense. I guess this is what I will lose if I swap this number. This makes total sense why I would lose this current number twice. And this also makes total sense why I would, since this number would be negative, so losing this number twice means adding this number once. But why do we have this plus I here, plus I? That does not make a lot of sense. I mean, I do not get this part. Why do we have I here plus I? Because of the index, I think. And what characterizes a minimum odd number? Whenever I replace, so if we expand this minimum even value with this value, okay, let's actually do this in Excalibur, of course. If we take this thing, Yo, yep. If we take this thing, and I hope the stream is fine because it did stop in the middle and my camera is also not working. Anyways, yep, this value minimum even. We saw from the question, from the solution, that minimum even for some number j is going to be j plus aj plus aj. And if we plug this thing in here in this formula, we will get something like, yep, you can like literally plug this in. Yep, like that. And yeah, so this is what would be added. This is what the answer would be if we do make this swap. And why is this? So these two signs would be negative. This would be negative. These two signs would be negative, minus and not plus, not plus. These would be negative. And hmm, hmm. So this is the original index. Makes sense. Makes so much sense. And this is the current index. And current index I is always greater than j, or even equal to j in some cases when we began. And this is what would be added to our initial value. And that is how we are updating our answer. And we are always adding this to the initial value because we only want to make one swap. And I do not get why this code was not working then, if that is the case. Hmm. Okay, how are we updating this thing? Minimum even and minimum odd. This part where we are subtracting these two values in minimum odd, that makes sense because since this number is at odd index, this is originally in a negative place. And now you are putting minus here, minus sign here in front of a number that is already at a negative place. So you are essentially adding this number twice. And that is what you do when you swap this negative number with a positive number. And that is what you will be doing. What the thing is, mm, why are we doing this with init? Why do we need this init thing? Don't we just add this to our answer? Because that would make more sense. And in both the cases, we have I in plus because this is what we will be subtracting from the other number. So why do we have init in this? Why are we adding this number to init? Why are we adding this number to init? We are going for initializing init. We are going from the starting till the end of the number and answer is changing. Ah, shit, that makes so much sense. We are not changing init, we are changing answer. And I think now I get this. Now I get this. And I'll remove my stupid solution. And for size n, taking the whole thing. And how do we get, like, yeah, that is the whole way that you take an input. Okay. And actually, long arrays equals 0 vector long a size n and for n I equals 0, I less than n, I plus plus, and we take in the current number in AI, and if I remainder 1, if I is odd, then we will subtract the current number, else we will add the current number to our response and we can, instead of finding the initial thing at the start, we can do something now. Yep, we can say long best negative number is the second number. Okay. If n equals 1 equals 1, return, that's not return, literally see out this, and also returns. I was also trying to use go to statements like this, and go to n, and here declare n, and there I would have see out refs, the result, and yeah, else we don't need else statement here. And then when n is not equal to 1, what we will have is we first have to initialize the best negative number to swap with. Best n is, let's say, initially the best n is going to be at index 1. Since we know that the length is not equal to 1, at least n equals to 2. Therefore, I will always have the element at index 1. So when we swap that negative number, what we will g- what we will lose is negative a1 minus a1, which we can also, and yeah, then I got this error here, cannot jump from this go to statement to its label due to some reason. I guess because we are initializing some number here, but if I were not initializing the number here, then it would be fine. Long, best positive number is going to be 0 plus, that is what I will be losing. That is what I will be losing. I will be losing this, the first number, twice actually, 2 into this thing, and minus 2 into this thing. And then here for int I equals 0, I less than n, I plus plus. If I is odd, then the current number is negative, and therefore answer or response is going to be maximum of its current value if I do make the swap, or if I don't, then since the current number is negative, I will be losing, I will be adding to its value 2 into AI, and what I will be losing is the best positive number. Now, since the current number is negative, it is also the candidate to be the best negative number to swap with till now. And how do I determine that? To determine that, we just make this minimum to the best negative number till this point, or I would be losing if I do make this current one the best negative number. What I will be losing is negative 2 into AI, and Why is this negative? Because this current number is odd and it is negative. And since I will be making this negative number positive twice over essentially, therefore 2 into minus a. Losing a negative number is subtracting that number, is which essentially means adding that number to that whole sum. I plus 2, nope. Now we have, since the current number is positive and if we do swap it, we will be getting a negative number. We will be subtracting that number. Therefore, minus 2i, and best positive is the minimum, because we this best n and best p represent the best value that we will be losing. So we want this to be minimum. Best p I plus 2 into ai. And hopefully it works, or maybe it doesn't. Not even for a single thing. Yes, of course, of course, of course. Because either this is the swap that we do make, or res equals maximum of res, or if n is odd, if n is odd, then n minus 1 or n minus 2. This thing added to the initial answer. So we do need, wait, res is long, long. Yep, res is long, long. I can make this one long, long. These are both long, long now, but we cannot just do this thing. We need to remember the initial value of this thing. That is why they also used the initial value long, long in it is this, and 16, and this doing it. Okay, that is still wrong. At least with my solution, I was getting the right answer, but here we're not. So something is wrong, clearly. Okay, should I still learn CP even though I'm not in to game development? Yes, you can learn CP. Learning CP is very good, not just because you can make new things and because of the flexibility that CP provides. Yo, hello. But because learning CP is hard. Not CP. Learning C++ is hard, and it is one of the hardest language that you can learn. And if you can master in some sense this C++, then every other language seems like child's play. If you understand C++, if you write code in C++ and then you see some Python code, it seems like English. It seems like plain English. It is very easy to understand that. First two were very easy, but others were hard. Yep, others were hard. I got the first two also, but yeah, the third one, I'm still trying to figure out how to do it. And yeah, the first two were easy. First two were easy. How much time did it take for you to solve those questions, if I may ask? I did the first one in 6 minutes, and the shit, my camera is also not visible. First one in 6 minutes, and the second one in 7 minutes, and that was fine. I mean, first one was a bit tricky. Second one was seemed easier, a bit easier than the first one. That is what I would say. And the third one, I tried so hard to get it right, so hard to get it right, but no, it just said no. And still, I mean, this is essentially the thing that they say in the editorial. This is essentially the same thing that I was trying in my dumb, stupid way, but they are the same thing. And my code was not working yesterday and it's still not working today. Something to be said. And that is pretty cool. And still doesn't work somehow. Wait, this is because I am very stupid. I have to add. Shit, shit. And if I'm going to do this, I should just s- put my ego aside and write this statement about res equals or plus equals if n is odd question mark then n minus 1, otherwise n minus 2. Okay. Okay. If I get correct answer on this one, uh, I will be a bit happy. Let's see. Okay, I cannot even submit somehow. Okay, submitting. I'm very sure it is a verb. There were two, three cases in that one, right? And we need to check maximum possible in each after case. Yeah, there were two cases. I mean, um, okay, I'm happy now. I'm a bit happy. If you look at this thing, and the question was clever. The question was clever. The way that they stated the question is clever because they said that at max they can play 10 power 100 turns. But the thing is, they do not have to play 10 power 100 turns. If you do some maths and logical thinking, you will figure out that the best move for Bob is to end the game for both Alice and Bob. So this in this whole game, either Alice is the only one who is going to play a move. And on her move, she either chooses two indices and swaps them, or she ends the game herself at the spot. And our task boils down to finding this best possible left and right indices, and whatever the change is to this FA function, output that change. And yeah, and that is what we did. That is what we had to do yesterday. Like we can change a higher negative position to a lower positive to increase FA, yep. And then we can also change a same parity number. If the array is very large, it will increase because of cost. Yep, yep, yep. We can, yes, that is what we can do. And yeah, at least now it is working. Yesterday I submitted a lot of code, but it never worked. 1, 2, 3, 4, 5 didn't work. Now it is working. So that is very cool. And just a sanity check. I will remove the whole thing and rewrite it again so that I know that how this thing is working. So we take in n and we create a vector of long a size n and long response initially 0 for int I equals 0 yi int I equals 0 I less than ni plus plus. We will take in the current I, and after that if I is odd then rest we will subtract the current value, else if it is not odd then we will add the current value. We have our thing, and if we do change let's say without change, orig, the original value is this, reg. But if we do make some change, it would be based on n's parity. And if you see, if n is odd, then the best possible change for numbers with the same parity of indices is going to be n minus 1. And if n is even, then it is going to be n minus 2. So rs right now is pointing to the best change swap of numbers with the same parity. And if we go less than n I plus plus, we will have long best negative number to swap with. And since we are supposing that we will first check if n is 1, then just see out whatever res is right now with a new line and return. But if n is not 1, then long best negative number to change with is a1. And let's make this represent these two numbers. Best positive number to change with is a0. And let's make them to represent that this is the value that I would be losing. This is the value that I would be losing when I make the swap with this number. And what will I lose? I will lose 1 minus 2 into ai, and in this case 2 into a0. Why will I lose this positive number twice? I will lose this positive number twice because in our original response, we had some number ai. This is a positive number. We had it added once. And since we are making this number negative, first of all, we will make this equal to 0. So we essentially subtracted ai and then we made it negative ai. Therefore, when we made it negative, we subtracted this again. So in total, the change was minus 2 ai. This is the change. This is what we gain because now the number is minus ai and originally the number was ai. So if we minus from target the source, which originally was, it will give us the change, and change is minus 2 ai. So if that is what we gain, what we lose is just the negative of this thing, which is 2 ai. And this is what we gain. This is what we lose. And yep, that is what I have written here. And this is also what I have written here. And for a negative number, if you begin with a negative number, a number that is originally negative, and convert that into a positive number, ai. So what you will lose is this number minus the target. Source initially is ai minus the target. What you become, that is what you lose. This is minus ai. This is what you are going to lose if you make this current negative number into a positive number. And that is what I have written here, minus 2 ai. And losing a negative number, that is subtracting a negative number, means adding that number twice. That makes sense. So why do I have the index added here? Because we can think of the, since this negative number, I will only be swapping this with a positive number with the same parity. And let's say the numbers are like this: a, my current negative number at index x, and my new positive number with index y. And yep. So when I make this positive number a negative number, what I will gain, what I will lose is minus 2ai, minus 2b, minus 2b plus y minus x and plus 2a. Why this thing? Because this number is currently positive and we are making it negative. So minus 2b is the whole thing that we will gain, and y minus x is written in the equation. That would be the cost for making this operation. And this number currently, which is negative, we are making it positive and it will become plus 2a. And in our equation, this part, we are going to subtract this thing from this part, from this rightmost part. And since we have taken this sign as negative and this sign as positive, and we will be putting a negative sign, so this is the eventual equation that we will get. And I think I'm not doing a very good job at explaining. Also, can be a mix of both. Yep, we only need to calculate what she can do after one chance. Yep. And when I discovered that, it was like eureka, eureka. And it was quite confusing. Like I was able to pass two pre-tests, but it gave yes, same for me. Difference between this and this is 2a. Yep, because of cost. Yep, because of cost, we are adding this index here. And I mean, but still, I'm not satisfied with my performance in this one. How do I add this to a review list? Let's do this. I mean, I can write the solution for this thing, but it doesn't make a lot of sense. If the current number is negative, then I will swap this with the positive number and maximum the current value. Or if I do choose this current number, current number is negative, so it will become positive twice, 2 into ai, and minus what I will lose, which would give me what I will gain. Or I could just make this sign positive and this one negative, and this gives me what now this is giving me. Wait, therefore this sign has to be negative now, because this is what would be added. Yes, to this other index because of the cost. And I can add what I gain when I put the best positive number here. And now, since the current number is negative, it might be a candidate to become the best negative number overall. And now we don't use the minimum function. We use the maximum function, because what we gain, we want to maximize it. Best negative, comma, what I will lose is minus I plus 2 into ai. Else, if that is not the case, then the rest is maximum rest and I minus 2 into ai. Since this current number is positive, we will be losing it twice. Plus what we will gain is best negative number. And this present negative number might be candidate to be the best positive number. The current positive number might be a candidate to be the best positive number overall, and that would be something like minus 2 into ai. And hopefully, hopefully, hopefully it works. Hopefully it works. Hopefully it does work. Or maybe it doesn't. Okay. False. No, 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 no. This is a negative number, so we will be losing it, adding it twice. And this is a positive number, so we will be losing it twice. Yep. And we are maximizing our gains in both the cases, and also rest. Shit. How can a human being make same mistake twice? Add this to the original answer. Add this to the original answer. Shit, okay, I expected this to work this time. Original answer is res, right? And then the current res or original answer, this is the change that I will gain. That I will gain. Yes, this is the change that I will gain. Makes sense. Plus I plus 2ai, the current number, because it is negative, I will be adding it twice. And the gain that I will get by swapping this positive number, best positive number till this point. And here also we are doing the same thing, but it just doesn't work. Somehow, minus 2i, we are adding this to the original number. Okay, that just doesn't work somehow. Even though it was working earlier when we had a different form. Res maximum is res comma original value plus what we gain after making after swapping this current negative number with the best possible positive number. That is what we have here. And if this current negative number could be a candidate to be the best negative number overall, and when the current number is a number that is at a positive index, then if we do make this swap with a negative number, this is what we get by swapping with the best negative number, and this is what we get by swapping with this current positive number, and we add that to our original answer. And here also the thing is correct. Res equals, if n is odd, we do n minus 1, and if n is even, we do n minus 2. So that is correct. Here also res is correct. Best negative is correct. Best positive is correct. We are gaining the best number twice, and we are losing the best positive number twice. Yep. Maybe because are we not supposed to make this change? No, we can make this change with the zeroth and the first numbers also. So why is this wrong? Wow, shit, 0 doesn't even make sense. Doesn't even make any sense. 0 doesn't even make any sense for this thing. How can it even be 0? We can actually bring out the big guns. Shit, since I'm using G++ now, I would like to use GDB. Yeah. Let's first of all, for now, just use Clang. Does it compile? It does not compile because Clang does not know those libraries. CP. Clang does not know those libraries. Shit. And if I were to use G++ for compilation, and do I have GTB? I do not have GTB. Something's wrong with this part. Long, best n. If I write this best negative number 1, if I write this equation in the terms that is written in the editorial, it would be something like this: 2 into a0. And for int I equals 0, I less than n, I plus plus. If I is odd, then I'll swap it with a positive number. So res equals maximum of res, yes, maximum of res, comma, org original plus ai. Since the current number is negative, I will have plus ai plus 2 into ai minus best positive number. And best n equals minimum of best n currently, or I plus 2 into ai. Else the rest is maximum of rest or original plus I plus 2 into ai minus 2 into ai minus best negative number, and best positive number is minimum of best positive number plus no minus 2 into ai. Okay, shit, I expected this to work, but no, now none of them are giving the correct answer. What the heck is even happening? What the heck is even happening? Original, we have original equal to this thing originally. And is there something wrong with this? None of this makes any sense. Even though it should, I hope it should. We have it equal to 0. Shit. There is shit. I just saw my stupidity and I won't even fix it. I will write the whole code from scratch. Shit. Uh, the mistake was this thing. Here I had to do rest plus this thing. The sheer stupidity. The sheer stupidity. Okay, it still does not work. It is still, but that part was a retard. That part was retarded. This mistake was retarded. Now it is correct. Now it is correct. That is cool. And best negative is this. That is what I will be losing. And best positive is this. That is what I will be losing. And if the current number is negative, if the current number is negative and I swap it with the positive number, this is what I will get. Subtract what I lose when I swap with a positive number, and here subtract what I lose when I swap this currently positive number, make this number negative, subtract this and compare positive with this thing. Wait, shit, okay, this is supposed to be positive and this is supposed to be negative. Now it is correct. Now it is correct. And shit, I'm very stupid. I'm very, very stupid. BLP and vector for long a size n and long res initially 0 for int I. That is not int I equals 0, I less than n I plus plus c in ai. And after taking in, if I is odd, then res minus equals ai, else res plus equals ai. Now that is correct. And long original value is equal to res, and res plus equals, yes, we are adding to res plus equals, if n is odd, if n is odd, then n minus 1, otherwise n minus 2. And then for n, although we need the best values, best negative is, that is what we gain when we add a negative value, is 2 into a1 minus 1, and long best positive value that we, what we will get is 2 into a0. And if n equals 1, then see out rest and return. So at this point we know that n is at least equal to 2, and then we can start iterating for I equals 0, I less than n, I plus plus. And if I is odd, response is going to be negative, maximum of the current response. And since the current number is negative, we will add this and 2 into ai plus best positive number, and best negative number is maximum. Since this is what we gain, so we are trying to maximize the current best positive number or the current number, which is minus I plus 2 into ai, else rest is maximum of rest, comma, again the same mistake, org. You have to add this to the original value, and here also original value plus I minus, since this current number would become negative, ai plus best n, and best positive, what we gain from this positive number is best positive right now, or minus I minus 2 into ai. See out this. And there is, like, of course, some meta level concept that is under the hood being applied here. Tags, data structure, games, greedy. Shit, there is no meta level concept. Let's submit the code for this one. See, and also my camera is messed up. It just doesn't work. Let me try to fix it. Okay, it does work. It does work. The camera is fine. Now it is working. That is cool. And I cannot submit this due to some reason. Why? To submit this, just go there, paste, submit. And this should hopefully work. Hopefully. Yeah. Yeah, I guess it is correct. Running on test 12. Test 12 is a long way from the start. Okay, so this does work, and this does make some sense. Would have been cool if I were able to do this in yesterday's contest, during the contest, but I was unable to do that. Anyways, let's move on to CP31. CP31, and yesterday in CP31 there was a question. Is my camera fine? Yep, my camera is fine. Yesterday in CP31 there was this question: controllers which I was unable to do, which we didn't even solve and submit. Yeah, it is fine. So in this, let's try to find a method. I read the editorial for this one. This is from ICPC. This is the ICPC question. Here you can see I read the editorial for this, and but now I do not completely get what was written in the editorial. So I want to just go through this thing and figure it out why it works and what it actually is about. And yeah, the stream is fine. Okay, it is taking long to load, but we don't even have to look at this. We know that we have something like this. So we have two numbers, and for every sign here, we either add or subtract the number. And the order of these signs doesn't even matter. So we can say P is the number of positive signs that we have, and N the number of negative signs that we have. Yep, and the two numbers that we have, let's say X and Y. They are X and they are Y. So what we need is for some positive number of X, let's say A into X plus, or we could even say minus B into Y should be equal to 0. That is what we want, right? That is what we want, because if we choose K X number of times from the positive side and Y B number of times from the negative side, this is what we want. A X equals B Y. And yep, so if we have chosen AX A number of times from this thing, we would have P minus A things remaining, and since we chose Y B number of times, we would have Y no negative N, we would have N minus B negative signs remaining that we have to choose. And since these signs would have to be positive, these signs would have to use X, and these signs would have to use Y, because since we are not using X here, then we must be using Y here, and since we are not using Y here, we must be using X here. So in total, we have A X plus this thing X, N minus B into X. And if we, this should be equal to this opposite side, which is by plus p minus a into y. And if we take x and y common from both the sides, a plus n minus b equals, take y common, and we have p plus b minus a. And we want these to be perfect, to be like divisible, to be factors, or we just want these to be equal to each other. And we can easily figure out, we have y, we have n, and we have p. What we don't have is a and b. A is the number of times that, but we do have one more thing. We have a x plus b y, ax equal to by, ax equal to by. So maybe we can write a in terms of by. So a equals b divided Yep, a equals b divided by x. If we write this, we plug this in, we have x into by divided by x divided by x plus n minus b into, we plug the same value in this part, we will have y into, and I feel like I'm making this overly complicated, more complicated than it needs to be. But anyways, let's see where we can take this. This is what we have, and this needs to hold true. And if this doesn't, how many problems you did yesterday, yesterday, I guess. Yesterday I did 2 problems in the contest. And if you are asking for today, if I have done any problems, only this one from yesterday's contest. Only the problem C from yesterday's contest. That is all I have done today. And okay, we can take B common and maybe get to some place. We do not know B. We do not know B. So let's factor out B. We know what X is, we know what Y is, we know what N is, we know what P is, we know everything else. We just don't know what B is. So let's find out B, take out B. And here we will have by plus nx minus b equals py plus by, wait, plus by. Yep, we have plus by there, minus by square. Okay, and this cuts this. Okay, we have nx minus py, this is py, this one, py equals, if we take p common from here, we will get 1 minus y square. And we would need our b to be a positive integer for all of this to work out. A positive integer or any integer. Integer would work. Integer. We just need b to be an integer. So we have n x minus py divided by 1 minus y square. And this thing has to be an integer. So when I divide this thing by 1 minus y square, I should get an integer. Therefore, I should get a remainder of 0 when I divide this thing by this thing. And that is a theory. Yep, only one, which was from yesterday's contest. I've only done one question today till this point. And this might be correct, but this is just a theory and I'm not very confident with this theory. Let's see how it goes. CD 1500 level. And one thing that I have noticed is, for these questions at higher ratings, their editorials say things in a singular line or word which are like whole topics within themselves. They just say use minimum prefix. What is minimum prefix? I don't know what is minimum prefix. So that thing has been a bit common lately with these questions. C++. Wait, how do we get the input? Yep, we have to change this whole thing. Int n, in n, and string s, c in s, and int p equals 0, n equals 0, and or we can do the smart thing. Int p equals count s dot begin, comma, s dot end, count the number of positive signs, and int negative equals count s dot begin, comma, s dot end, count the number of negative signs in the whole thing, and we have already used that thing. So let's call this q as in the number of queries, and while q minus minus int x and y, c in x and y, and yep, let's say long numerator as in num numerator is this thing, n into x minus p into y, n into x minus p into y. That is the numerator, and long, yes, we are using long. Denominator is going to be 1 minus y square, 1 minus y into y into y. And now if remainder, now see out depending on the remainder that we get when we divide numerator with denominator. Numerator, remainder with denominator. If we do get a remainder, then no. But if we don't, then yes. And I just hope that this thing works. That is all I can do. And it doesn't. It doesn't work. It doesn't work. It doesn't work. It doesn't work. Why am I saying? Wait, why are there so many yeses and nos? Okay, this is more no's than I ever need. Why do I have this many yes and no's? Shit, because okay, it is still wrong. This one is right. That is wrong. Why am I saying no? So there must have been something wrong with the maths. There's something wrong with the maths. Maths is not mathing somehow. Okay, we can skip this question for right now, and I would like to actually move on to the next question and start our stopwatch and try to solve that new question, and we can come back to this question later. Fresh start with a new question. Okay, let's go. Yeah, palindrome basis. You are given a positive number n. Let's call some positive number a without leading zeros palindromic if it remains the same after reversing the order of its digits. Find the number of distinct ways to express n as a sum of, find the number of ways, distinct palindromic integers. Two ways are considered different if the frequency of at least one palindromic integer is different. For example, this is a palindromic thing, and 5 equals shit, not just two palindromic numbers, any number of palindromic numbers. But this thing and this thing are considered the same. Shit, okay, this is like coin change, but more restrictive. But more restrictive. And what is the maximum value of n? N can be pretty big. 10 power 4, there can be 4 digits in n. And when there are 4 digits, right? 10 power 4 into 4 is this number. What is the maximum number of palindromes that we can see? Maximum number of palindromes with one digit are like 9, all the numbers from 1 to 9. And when we have 2 digits, the maximum number of palindromes is still 9, because 1 1, 2 2, 2 3 3, and so on till 9 9. It is still 9 palindromes. Here also it is still 9. When we have 3 digits, though, we can have some variance. For the first number, we have 9 choices, anything. And depending on those 9 choices, on the second part, I could have any number, on the second, on the middle part, I could have any number. So 9 into 9, 9 into 9. But the third part, I have to have the number that I began with. So there are 81 palindromes in this range. Okay, I think that logic is correct, because I have 3 possible places in a 3-digit number. I have 3 possible places to put the number. Let's say I put a number x, and this number has to be same whatever I put here. These two have to match, and this number can be anything. And for this x number, I have in total 9 choices, and same for this 9 y number. So 9 into 9, 81 possible palindromes when I am dealing with the 3-digit number. But when the number is 4 digits, then also it is the same. Then also it is the same, because whatever I have here, we have to have the same number here. Whatever we have here, we have to have the same number here. And this x can have 9 values, and this y can have 9 values. In total, 8, 81 palindromes. And yep, then we go to a 5-digit number. 5-digit number. For a 5-digit number, we have this thing: 3, 4, 5. The total number of palindrome: x, y, and z. This z can be any number that we want. Yep, this can be any number we want. And let's go with a finer margin. And let's say, yeah, we can have at most 4 values here, but we will not consider the case when we will not eliminate the cases when we have uh, when we have 4 here, but we have values which are lower than 4 here. And actually the maximum number that we can have here is 3, which is a palindrome, is 39993. That is the biggest number. Smaller than this, that which is a palindrome. So here at max we can have 3 choices here, and for this we have 9 choices, and for this also we have 9 choices. So 81 into 3, 243 in total palindromes in this cases. So yeah, that is something that we just happen to have. So if I go and I make a list of all of these palindromes, in total how many will I have? For 1 digit, I have 9 palindromes. For 2 digits, I again have 9 palindromes. For 3 digits, I have 81 palindromes. And for 4 digits, I have 81 palindromes. And for 5 digits, in our special case, I have 243 palindromes. And 9 plus 9, 80, 90, 180, plus this thing, which is 3, 4, 23. 423 palindromes in total. And we can actually create a vector of these things. We can create a vector of these things, and this is dynamic programming. This is dynamic programming in which using tabulation we can use this. Now at this point it is just like the coin change sum, and the number of coins is 423, and we can begin from here. I think it is cool. how many problems, and your college and degree. I'm doing BTech. Well, I have taken admission in a college, but I do not go there. And 9 into 10. I don't get the 9 into 10 part. We are referring to something here. But okay, this is the total number of. Now we can think of this like a coin change problem, simply where we have this thing 423 number of coins. This is the total number of coins, total amount of coins that we have. We just have to create a vector with this, and the coin change problem where we are finding unique sums, and that is cool. So how do we create this thing? Like, look at this. This is coin change. So let's create a vector for this. Boilerplate, int n, c in n, and wait, that is not how we are getting the things. Yes, that is how we are getting the things. And before here, we will have a vector of integer. We'll call them pal, right? Pal makes sense. And then void fill pal function, which will be called, and this function will fill the pal vector. But how is it going to fill the vector? So let's say number of digits initially is 1. When it is 1, it would be stupid to just go through all of these numbers and check if it is a palindrome. Wait, we can actually do that. We can actually do that because n is 10 power 4. We can actually do that. Yep. Yes, we can. Yes, we can. We can actually do that. So we can, yep, we can actually do that. Const in range is 4, 4 into 1e or 4e5. That's it, plus 1. Just to be safe. And for int I equals 1i less than equal to less than range I plus plus. And if the current number is a palindrome, we will add it to our thing. And how do we check if the current number is a palindrome? We will do long. No, we can do int op initially is 0. We'll say op equals 0, and we cannot change I. And org as in original is 0, and we will put org equals I, and we will say while original number, whatever op is, op into 10, op equals op into 10 plus org remainder 10, and org divided by equal to 10. And later, if opposite equals I, then palindrome dot push back this number I. And pretty sure the spelling is wrong. BA pushback. And that would be nice enough to find all the palindromes in this range. And now we will like to have a vector, a DP tabulation table, so called. We will call it tab, and size would be n plus 1. And we will start iterating for int I equals I for each coin. Yes, we will start iterating for the coins internally, and externally we will start iterating through the numbers that we have. Yes, and is there some initial thing? Nope, initially everything is 0. Initially, initially, since we are not using any coins and our target sum is 0, our target sum is 0. There is only one way to reach, and this should not be like this. This should be pal dot size, and let's give it an integer. Nums equals pal dot size, and for initially I think I have to fill this vector with 1. Fill tab dot begin, and actually I can just do this here. For int I equals no. Shit, yes, okay. This has to be vector long integer and tab n plus 1. Initially when the target sum is 0. When the target sum is 0, using when the target sum is 0, I feel like I have to use mm, oh shit, okay. All we have to do is tab 0 equals 1. Yep, now it is initialized. Now it is initialized, and this just tells me how I'm not doing DP correctly. Nums I plus plus, and for int I equals 1, I less than n I plus plus, not less than n, less than equal to n and I plus plus with the current coin. And if I is my target sum, if I subtract the value of the current coin, which is, let's call this coin. I do not want to call this coin. That just makes the whole question easier. If target sum minus this current value, if that is some positive number, then nums I target sum plus equals pal j, the number of ways to get to j, tab instead of num. And here we do cout tab n, and hopefully that is correct. I mean, I mean, I mean, like, shit. Something went wrong. Something did went wrong. J is the, yep, jth palindromic number. That is correct. And okay, shit, yes, we also have to take the modulus. We don't actually have to take the modulus at this point. Tab I modulus, modulus with capital. And what is capital M? It is cons int m equals 1 e 9 plus 7. That is what it is. And we are calling the fill pal number, but we are not checking if it is correct. Let's see beforehand. See out pal, how it turned out. Print the vector. Wait, though, that is a bunch of polynomial numbers. That is a lot of palindromic numbers. And but the answer that we are getting is wrong. We have tab 1 equals to 0 because n, because when we want to get to a sum of 0, there is only one way to get there. If this thing greater than equal to 0. My bad, my bad. Okay, it is still wrong, but this is very close to the correct answer. We are surely not doing some double counting, right? Not. Wait, what does this even mean? Tab I minus the current sum minus this thing. Okay, that is kind of messed up. I minus pal j. Shit. It is correct. And it should have been correct in the first try. You working in any company right now? Nope, I am not. I'm just in my college. Where are you from? I am from Meerut, the same city that Bassi is from. And shit, I guess I'm not the best YouTuber from Meerut because Bassi is from here. He has more subscribers. And okay, then we will have a vector of integers. We will write this whole thing again and void function fill val, and this will not take in anything. We will have const int range equals 4 4 e 4 plus 1 plus 1, right? 4e4 plus 1, that is the range. Yep, 4e4 plus 1 just for good things, and int m equals 1e9 plus 7. And here we will have for int I equals 1 I less than n I plus plus, or n I less than range I plus plus. And internally we will have in original equals I, and int opposite equals 0. And while original we will do op equals op into 10 plus original divided by 10. Original remainder with 10, modulus with 10, and original divided by equal to 10. And yeah, if original or if opposite equals I, then val dot pushback I. We will actually call this function right here, fill val, palindrome. And in here we have n and vector integer tab n plus 1 that is going to the side, and tab 0 equals 1, and tab I represents the number of ways we can get to the sum of I. And then let's also have int num equals pal dot size, and for int j equals 0, j less than nums and j plus plus, and for sums int I equals 1, I less than equal to n I plus plus. And if to get to this sum I use this number, which is the current number that we are going through, which is pal j. If this number is greater than or equal to 0, the answer would be tab I plus equals tab the number of ways to get to that sum, which is pal j. And also tab I modulus with m. Yep. And at the end, cout, not res, but tab n. Tab as in like tabulation. Correct. That seems to be correct. And if we submit, it should be correct. Hopefully. Wait, I don't want to change my compiler. Hopefully. Ah, time limit exceeded. That is unprecedented. How did time limit got exceeded in this? Maybe in this operation, this one might be slow, this operation. But here we have n square, and what is the size of this internal vector? 498. 498 is not a very big number, actually. Shit, what we can actually do is shit, yes. We can fill dp, fill dp, fill table tab. We can call this function, and this will fill this for the entire dp. Yeah, but no, this might mess up. This might actually work if I use a two-dimensional dp and get answer for specific values. That would be nice. Or this is nice. This is nice. This is correct. Okay, this will work. This will work. We will initialize this table. We'll delete it from there, and we will have it here. Fill tab, and here we will change this to be equal to the total range, and internally, yeah, we will initialize tab 0 equals 1, and int nums equals val dot size, and for int j equals 0, j less than val dot sa j less than num and j plus plus, and for int I equals 0, I less than range I plus plus. I is the target sum, and if I minus the current number that we are talking about, which is val j, if this thing is greater than 0 or even equal to 0, then tab I plus equals tab to get to that point, which is val I minus val j. And immediately after that, if tab I greater than m, then tab I modulus with m, then tab I modulus equal to m. And this thing would be filled. And we can call this right here, fill tab. And when we are inside, we'll just take this thing and see out tab value for n. Okay, that is wrong somehow. Yes, of course. That's now that's correct. I think, yeah, not that. I think I pretty much know at this point that this has to work. This has to work because we are not doing anything bad. Okay, 29 minutes. We can call it 29 minutes. Shit, how is it that some problems are easy and some are not so easy? Can you brief? Okay. Not that it is not that I do know some things, but okay, to be honest, I have I try to spend time learning things, and because like I do not want to learn things, and okay, how do I explain? I did those streams on assembly language, these streams on assembly language, and see, I didn't get any views, and views was not the main thing that I was doing these streams for. The main thing that I gained after doing this whole stream on assembly language was that now I know internal things which people would not know, or I would not have normally known if I didn't know assembly. Now I know assembly, so if I see some low level description of some concept, then I have some notion to make understanding of that thing. So that was cool. And I wouldn't have completed the assembly book that I was reading, doing all of this from, if I was not streaming. And therefore, streaming has been a very good thing, one of the best things I would say, for improving my skills. And yeah, what do I know? That is hard to say. What do I know? I just try to learn things. Yeah, sometimes learning things is very hard, very hard. Like right now, it took me more than 1 hour to do that C question in yesterday's contest, and I have spent so much time in on this question, and I haven't been able to do this somehow. And it took me 29 minutes to do this one, even though this was very similar to DP, dynamic programming questions that I have already done. This question is very similar to this one. There are just so many factors and variables while solving the questions, and coin combination 2. This is the one, and these two are basically the same thing. This and that question, they are basically the same thing. Literally the same thing. Shit, okay, my phone is actually going to die in some time. So let me do another question. Like MERN or SMT. I don't know about SMTG, but I have built some apps in MERN. I built, but they are not like very good. You can go to my GitHub and see them, but the things that I have built in MERN are not very good, and I'm not very proud of them because they are not very good. I built a chatting app, and I built with my friend a website for someone that he knew, and that person gave us money, some actual real money. That was cool. Yeah, the things that I have built, are not very wonderful. So next year, when I am very good at competitive programming, I will start building development things, things that I am proud of, things that I can show to other people and say, look at this. This is what I did. Some good things. And in this question, let me guess what the tags are going to be. First of all, DP, of course, dynamic programming is something that we will see there. And besides dynamic programming, I guess maths, dynamic programming and maths. Let's see. Yep, dynamic programming, maths, brute force, and number theory. That is fine. And that is cool. In C here, this was a division 2 editorial. The number of palindromes is relatively small. Yep. The rest of the problem is quite similar to classic partitions problem tutorial. First, we need to observe that the number of palindromes in this is relatively very small. The number of 5-digit palindromes is are 300. Enumerate all 3 digits less than 400 and append the first. Okay, whatever. Yeah, that is the same number that we ended up with, 498. Now the problem can be solved just like a classic partition problem with DP and into M. Bonus task. Try to optimize space complexity. We did optimize space complexity. Reverse. Reverse a number. Return R. Yep. Bool palindrome. Is it palindrome? Okay, they have written functions. Okay. And then that is exactly what we did. That is literally exactly what we did. We calculated everything beforehand, the whole palin vector and then the DP vector here. Yep. And but our space complexity is better because we are using a one-dimensional array, and in that question they are using a two-dimensional array. So our space complexity is a bit better than theirs. Okay, and what is that? IIT person creating a contest on code forces. That is cool. And now we can move on to the next question. So, what are your plans? My plans are to be really good at competitive programming, even though you're not watching right now. But my plans are for this year to become really good at competitive programming, and then next year explore new things, build development things, websites and stuff, and be, yeah, just learn new things and improve myself. Line Empire. Let's solve this question too. You are an ambitious king who wait. Yeah, let's solve this question. Yep, my phone is going to die, but anyways, let's solve this question. You are an ambitious king who wants to be the emperor of the reals, but to do that, you must first become emperor of the integers. Consider a number x as the capital of your empire is initially at 0. There are n unconquered kingdoms at positions. All of these till n, you want to conquer all other kingdoms. There are two actions available to you. You can change the location of your capital. Let its current position be CI to any other conquered kingdom. Let its position be C2 at a cost. This is going to be the cost A multiplied by the absolute difference between the distance, okay? Or from the current capital, let its current position be Ci. You can conquer any unconquered kingdom. Let its position be C2 at a cost of B into the distance of the this thing. uh, B into the absolute difference of their distance. You cannot conquer a kingdom if there is an unconquered kingdom between your target and your capital. So I can only conquer them. Okay, if I have only conquered all the kingdoms in between, only then I can conquer this current kingdom that I am at. Okay, note. So, hmm. Okay, that seems okay. Note that you cannot place the capital at a point without a kingdom. In other words, at any point, your capital can be at 0 or one of the x till n. Also, the conquering a kingdom does not change the position of your capital. That makes sense. And this one seems easy. Hopefully, I do implement this correctly. And x can be pretty big. And these are the inputs. Okay. And x is hopefully in sorted order. It is in sorted order, thankfully. And we have a and b and n. That is how we take the input. And n and a and b, c and n, a, b. Hmm. For every kingdom, since it is a monotonic function, right? Yeah. For int I equals 0, I less than n, I plus plus. And also I will have a vector of long, let's say a x, let's call it, of size n, and we'll take in c in x. What the heck is that? For long, a in x, c in a, that is just the terms have tabled. And now for int I equals 0, I less than n, I plus plus. Actually, I think I don't even have to save all of these kingdom locations, because whatever the kingdom is later, it doesn't matter. I cannot go there, I cannot conquer it unless I have conquered all the kingdoms till that point. So initially I start with 0 int or long position is 0. So I have one choice, either, okay, and I have to return the cost. For each test case, output a single integer, the minimum cost required for all the kingdoms. Cost equals 0. Long cost equals 0. And for every kingdom that I'm at, I have two choices, either to move my capital, since I'm currently at an unconquered kingdom. If I conquer this, then this, wherever I am currently, either I conquer this kingdom right now, wherever I am, then this is going to be the cost for that, or I move my capital to some other place and then conquer the kingdoms. And it would it be always best to move my capital to the closest city to this city? A greedy approach. Would a greedy approach result in a possible best possible answer? I don't think so. I think this is going to use dynamic programming. We're solving A and B consistently in Div 2 and 4 questions in Div 3. How much on the CP31 sheet I have to do? Like in very general manner. Yo, how are you? I guess that is something you will discover as you go along and would also depend. It does not matter on the amount of questions you are doing and more on how much you are studying and giving thought to those questions. Because the earlier questions that I have done in the CP31 sheet, my main focus was just getting these questions done. But now the quantity is not my main measure. My main measure is how well do I get a singular question. That is my main measure of success, you could say. And hello, New Year. Hello, how are you? I woke up at 12 a.m. Shit, what is the time there? It is about 3. You woke up at 12 and slept at 4 at afternoon. Shit. Jet lag. Are you already in Japan? Shit. This is a dynamic programming thing, but this doesn't feel like dynamic programming. Let's say I'm at some position, then there is another kingdom, now new kingdoms all the way. And let's say this is unconquered, so I must conquer this. But before conquering this, I am right here. So either I conquer this directly or I move my capital to some place and then I conquer this. That would be kind of like, hello, that would be if I do see, check out every position that I can move to. Well, what I do know is this cost is increasing at a constant rate. Okay, what would be the cost of directly conquering the kingdom right now? It would be, let's give these names. This is x1, this is position x2, position x3, position x4. And the cost of directly conquering right now would be some number b into x4 minus x1. That is the cost of directly conquering the kingdom. But if I do make a move to some place, with that move, and but shit, if I do actually make a move and I'm not currently there, then whatever that move is, it is going to cost something, and it would have been it would have been better if I did make my move earlier. Let's say if I'm going there and yep, if I'm going there and I'm going to make this move, moving my capital from here to this place right now to make to reduce the overall cost for this according to some measure, I should have done this earlier so that I would have reduced the cost of getting here. So I guess a greedy algorithm. But mm, okay, I think my camera. No, my camera is fine. My camera is fine. Not for very long. Not for very long. Uh, yes. If I do make a jump, it would be only best to jump to the thing just before me. Yes. So if that is cool, that is cool. So either I conquer this city directly or I jump my capital here and then I conquer this. and whatever cost is the minimum, depending on that, I will change my capital and I will add it to the cost. Okay, yes, yep. Cost, I have the cost and I have the position. So if I do long JMP cost when I do make the jump, and I will make the jump, we can start with 1, right? No, I don't like starting with 1. If I do make the jump, what is the last index that I was at? I minus 1, but currently I is 0. So if I, only then do all of this. Else, yeah, instead of checking this every time, I could just start my loop at 1. And cost equals cost equals wait, A or B for changing my capital cost is A, for conquering my cost is B. So B into A0, A0, B into A0. What is A0, you might ask? It is nothing. A0 is wrong. A0 is nothing. This is the real juice. Yes, and now I know that last city always exists. So long GMP equals, if I do make the jump, I will make the jump to the last city, and making the jump to that point would be A into my current position. My current position would be before that thing. Yes, my current position would be before that thing, and so A I minus 1 minus cos this cost to make the jump, and to conquer this current city, the cost would be A I minus cos. And you might ask again, what is AI? AI is nothing. So that would be the cost for making the jump. And since I would have changed my position, this would be xi minus 1. And long con cock as in conquer, b into xi minus the current position. Now, if making the jump, cost for making the jump is greater than cock, shit, okay, not just this shit. No, I think the logic was correct. I think the logic here was correct. The logic here was correct that if I want to conquer this city and I am currently there, conquering this city directly and then jumping here, or conquering some intermediate. I will be conquering every intermediate city and jumping to some intermediate city and then conquering. And I think my camera is still working. That is amazing. I have a flight to Tokyo at Saturday night, and I'll be reaching Tokyo by Sunday morning, Saturday night, Sunday morning, and I guess you would be going over the Atlantic Ocean Pacific Ocean, my bad. And because that is the shorter way, even though the map that we see is we have Europe in the middle, you won't be going through that route, I guess. This thing. The doubt that I am getting is even though greedy is fine. Greedy is fine. Shit, greedy is not fine. Because when I make the jump and then I go further, because when I make the jump and then I conquer this current city, then my position has changed, which affects everything that is to come in the future. But somehow feels like this logic is somehow bulletproof. Yes, yes, yes. Everything doesn't. Okay, my phone is now started to charge, but my laptop is going to die. Yeah, I'm not even in the middle of the camera or in the middle of the night. I think greedy algorithm should work here. Greedy. If I make the best possible choice right now, but my position is changed. If I do make a jump and then I go there, my position is changed to some other position, and that affects everything. But if I do not do that, let's say when I go there, and if I do jump, if going there directly was better than making a jump and then going there and then going there, then and when I'm here, let's say it is much better to come here first and then make a jump. So I want to get here. So I would have to jump here and then here. And how would it have been if I did make a jump in the first place and took that added cost and took that added cost? But then I will be reducing that other cost. Yeah, this is not going to work, but still, I will write the code for this thing. And I should like actually plug in my laptop, but that would stop charging my phone. Okay. I feel like exploring the world. Yep. Maybe well, I have very poor geographical knowledge. That is fine. Uh, exploring the world. That is cool. How much does it cost to explore India? Like I like nature. I love mountains, snow, etc. I love to write poems. So natural beauty seems cool. I mean, it is very cheap if yeah, it is very cheap if you come here. It would be very cheap to just go to places if you use the public transport system, but I guess you wouldn't want to use the public transport system. It would be harder for you to use it compared to an average Indian. You'd attract attention, a lot of attention, and people would come to you and they would say, ask for a selfie or something. So it would be harder for you, but yeah, you can manage. I mean, yeah, it is not very expensive. It is fine. And you don't like to write poems. That is very beautiful. I also know a few poems by shit. What was that poem? Shelby recited that poem in. Yep, you will be famous. You will be famous. People will ask you for selfies, and you will feel like a celebrity. And shit, why can I not remember that poem? He said, oh shit, okay, I'm very retard, and I do not want to look it up. Yes. Shit, why can I not remember? It is like just at my mouth, in my mouth. Yes, I was angry with my friend. I told my wrath. My wrath did end. I was angry with my foe. I told it not. My wrath did grow. That is A Poison Tree by William Blake, I guess. Yeah, that was a nice poem, even though it took me like a millennium to remember it. And time is ticking, and greedy algorithm is not going to work. But still, let me just implement it, even if it doesn't work. Cost plus equals cock, yes, of course, and else. This is totally not going to work. Yep, this is not going to work. This is literally not going to work. This is not going to work. Yep, nope, this ain't gonna work. And yes, my camera is down because my phone is switched off. Yeah. Mm. Okay, it doesn't work. And cost in this case plus equals GMP jump. But I just feel like this logic was cool. If I am currently, these are the places, and if I am here, and if I am here, and this city is unconquered, and I can jump to any of these cities in the middle, and then I conquer this, let's say, I jump to this city and then conquer this city. Then it would have been better if I had jumped to this city when I was trying to conquer this city, right? It would have been cool if I did that and that before moving there. Or, yep, I think a part of me feels like this is correct, and a part of me feels like, what the heck is this? So position would be new one. I A singular integer representing the cost. All right, minus is amazing. Minus, why? Huh. Jump wait, a can be negative. A and b are not negative. So why is this negative? Cost, okay, jump equals a into x I minus 1, I minus 1, and I minus 1 is always greater than this thing, and xi minus xi minus 1, that is the current position, xi minus xi minus 1, that is also positive. And in this case, xi, the current position, minus the last position, POS, that is also positive. That is shit. Okay, this thing changes to xi. My bad. Not xi minus 1. Okay, 0. We begin with this cost, b into x0. And how is it 0? B into x0. How is the cost? Am I taking the input correctly? N, A, and B. Yes, I am taking N, A, and B, and then X of size N. And we are taking everything inside X. Then position initially is 0. Aha, right. And then we are adding stuff to our cost no matter what condition we go in, and then we are outputting that cost. Okay, 0 doesn't make any sense. 0 literally doesn't make any sense. Should 0 literally doesn't make any sense. Long cost b into x 0, and yep, and just a sanity check, that is the location of the thing that we are going to. Hmm. Okay, it is always 0. It is always literally 0. I equal, okay, x n. Yes, x n x is the thing that we are going with. Shit, it just doesn't work. Yup. Ah, your skin gets red in heat. That is very mm, white thing to say. I've seen many vloggers saying India is bad at destination, but why? I mean, different people have different kind of experiences in India, I would say, and you could because there are a lot of people, the population is just immense. Like the most populated country, India is the most populated country, so and generally you would find people of every kind in every place at every place, and the majority of people here in India, they are poor. The majority of the people are poor, and so when they see someone who has more money, and uh, this is not the best description, but I'm trying my best. When a poor person, not just an Indian poor person, when any poor person sees that there is this other guy who has come from a different country, so he must have a lot of money. And maybe if I do something, I can feed my children today, right? Maybe I can get something good. And that is not just a Indian thing, that is a poor thing, poor people thing. And that actually makes sense. But I would not dehumanize poor people. I would say some poor people is not even the best fitting word. Some people who do not have money, all of them are not like that. Some people will be very, very kind to you. Some of the most kindest people you would meet like that. Some people who do not have money, they could be the most kind people that you ever see in your life. And there is a saying which I like a lot, that is, whatever you say about India, the opposite is also true. You can say there are poor people in India, but you would say there are billionaires in India. You could say Indian education system is bad. You could say Indian education system is one of the best. You have IITians. Sundar Pichai is the CEO of Alphabet, and the CEO of Microsoft is also Indian. And Agarwal was the CEO of Twitter. He was also Indian. So whatever you say about India, the opposite is also true and depends on the observer, I would say. Why the vlogger visit those poor areas? Well, that is up to them. If that is the image that they want to create, then they will go to those places and that is what they will present to make their view seem more reasonable by capturing the worst part of a country and saying that this is the whole country. But that is not true, right? That's sad. Yep, that is sad. That is sad. And yeah, that is sad. If you have a objective of finding the worst things in a country and you go to the worst places and you film that and you show to other people that this is what this whole country is, then that is not good. That is not good. And I would not even think that it is even possible to show all the sides of any places. I mean, it would be hard for even me who lives in India to describe India because there are just so many things, so much to take in. And yep, that is what I will say about that. And greedy algorithm doesn't work. Greedy algorithm doesn't work. And zero is unprecedented. Literally. What do I have in X? Okay, everything is zero in X. So that makes sense. Long, long. Oh, because I was not taking a reference. It was a copy operator the whole time. Always has been. See, greedy algorithm doesn't work all the time. Greedy one doesn't work all the time. But I thought this should work in some cases. It is working in some cases, but it is not working always. Mm. Man, New York is full of trash at night, full of smells. Lol. Shit, that is sad. Should smell. New York smell. Should I have heard about this? I've heard about this that New York smells very bad, very bad. And yeah, a friend of mine told me, yeah, New York smells very bad at times, or maybe always. I don't know, but yeah, I've heard about the smelling problem in New York. Something might be wrong, something might not be wrong here. Okay, I got the right answer for this massive number. Wait, maybe if I think about this more mathematically inclined way, then it would be cool. So you hit gym and code CP all day, right? Which year are you in? I'm in third year and I do not go to gym. I just exercise at my home. Yeah, I do not go to gym, especially at night. Shit. And I think there were covers over sewers in New York, and hot steam used to come out of them, and homeless people would sleep on those steam things so that they are not cold at night. And then New York changed the way those grids were so that it would be very painful for anyone to sleep on them. And And that is what I heard. Hmm. Uh, yeah, every place has stuff, mm, bad stuff, good stuff, even empires, line empires. Shit. Okay, let's think about this in a more mathematically inclined way. It's been 2 hours and 55 minutes. Okay, so what do I actually have? Here I have places, locations. Okay, and let's write down the costs. I have an integer a and an integer b. And to conquer, whenever I conquer this place, the cost would be b and this distance, whatever that is. And if I conquer this place from here, cost would be b multiplied by this distance. Let's call it x2, here x1, and then cost for that place would be b into x3. And whenever I move certain distance, not move but conquer, I could conquer this place directly or move my capital and then conquer. I have to conquer every place, so that is one thing. Wait. If I wanted to conquer every place, right? Every place, if I have to conquer every place, then I can ask myself, I can ask myself in this given interval, um, what would be the best place to jump? If I do jump, if I do make a jump, what would be the best place to jump at? But that also is not pretty cool because there's just I could be making a lot of jumps instead of a simple thing. Instead of making a singular jump, I could be making a lot of jumps. And if we have something like this is sorted. At least it is sorted, especially at night. And in New York, you can see many homeless lying on footpath. Yeah. Every place has their bad things. Friend of mine has been to a hill station in India. He said he saw nature at its best. Okay, and said that he never seen nature so beautiful like that. That made me curious. Yep. Could you show the question? Question is this, Mr. Modi, and this one. Yeah, hill stations here can be pretty beautiful, and also the aroma, I would say, the scenery, the colors, they can be beautiful. And like hill stations in India could be beautiful. Similarly, the night sky, not sky, but the buildings could be very beautiful in New York when you are taking a walk in the middle of the night at Times Square. It could be beautiful. So, and yeah, it is just very subjective, and everything is good, everything is bad. Generally, we can agree for things that are definitely bad. This is not a philosophy session, and this is the question. And how do we do it? This is the URL. Okay, for any question, I heard this from Donald Knuth. Whenever you see a question, break it up, break it into the smallest pieces possible. Let's say for this thing, I okay, initially we are at position 0. Then there is a palace empire at position 3, and then at 5, then at 12, then at 3, 13, and let's say that is all. And For this place, if I want to conquer this, I cannot go there. I must conquer this. Here A is 2 and B is 7. So to conquer, the cost would be B. Yep, the cost would be B. So B into 3. 3, B is 7. So here, if I conquer this directly from here, cost would be B. Now, I have a option, choice. Here, the distance is 3. If I do make this jump, shit, yes. Whenever I conquer a city, I ask myself, do I make this jump? Is this going to help me for anything that is to come? If I do make this jump, then making this jump will take some cost, and which is 2 into this distance 3. So 6. That is the cost that I would have to pay. But if, and after that, the next thing that there is for this place, the cost of conquering this from here, or not simply this. When I make this jump and give this much money, 6, handle this much cost of 6, I would be reducing a lot of, yeah, I would be reducing a lot of cost, because jumping here right now would save me a lot of money for all of these points, however far they are. And I can actually, wait, wait, if I can, while I'm taking this distance, I can add all of these up. Yes, shit. Yes, I can do that. I can add all of these up. And since if I were to jump simply from here, simply from this point, then to all of these points, let's say this is x2, this is x3, this is x4, and this is 0. This is 0. So if I were to jump here directly from this starting point, then the cost would be this thing, B, not for jumping, but for conquering. The cost would be B into x2 plus x3 minus x2 plus x4 minus x3, and x2 minus, let's say, initial position is x0. If that is the case, what does that leave us with? X2, x2, x3, x3, shit, x4. That, like shit, that literally makes more sense. X4 minus initial cost, this thing. So that is the cost that I would have to pay to conquer all of these from start to finish till that point. And if I do make the jump though, I would, the cost, wait, the original cost would be this much. But if I do make the jump to this current place, then the cost would be 6 plus b into x4 minus, I would be at this place, x1. So whenever I make a jump, I can ask myself this question: do I jump here or not? And that seems to be very feasible. That seems like fine. Seems like it would work. And can I try? Yep, of course, of course. It's square looks W at midnight. Yep. I gotta leave. See ya. If I visit India someday, I will let you know. Yes, I can guide you. And like full nature, like my friend saw, and I'm not interested in any slums like vlogs. Yeah, okay, we will have fun. If you ever come here, just let me know. Maybe on Discord or on a stream, and it would be cool. And of course, you can try. You don't have to ask. Shit, no, you don't have to ask. Just try. Just do the thing. And Java is fine. Uh, okay, Java is fine. Java is a nice language. We do not say bad things about Java. Int n, t in n, and not just n. Int n, b, a, b, get taken. N, B, A and B, and then the vector for vector long int would be fine. What is the range? 10 power 8, that is like just at the cusp. Int A, let's call this pos n, pos n, and then for int reference x n pos cn x, and yeah, long cost equals to 0, and for int I equals 0, I less than n I plus plus. So whatever place I am at, I will have to conquer it first of all, or and pos equals int my initial position is 0, current position is 0, and from whatever my position is, that is the best possible position to be at this till this point. So cost would be increased plus equals position, current position, which is current position or the current kingdom position, pos I minus pos, that is the distance, multiplied by b. Now I need to ask myself the question, do I jump or not? Do I jump? So what would be the cost of jumping? Int, let's say long JMP, the cost of jumping would be A into, since I'm jumping to this current position, pos I minus wherever I am. This is the cost of jumping. And if jump plus the cost of going, this would be the cost that I would have to pay for jumping, and then the total cost if I go from this place to all the places, then the cost would be um, the end thing, pos dot back, so a into, oh yes, a into, not b into, b is for conquering, b into pos dot back minus the current place, which is pos I. So that thing, wait, my bad. That thing making the jump is more costly than going to all the places from wherever I am at, which is pos dot back minus current position. Wait, if jumping is lower or even equal to, I will make the jump, and making the jump would increase the cost by the jump price, and pos would become pos I, the current position, and again see out cost. Hopefully. Okay, why is it 189 in both the cases? How? What is the cost for jumping to the current place from my current position? For B is the cost for conquering. The cost for conquering multiplied by the difference in position is the position of the current castle empire minus my capital's position. Add that to the cost and then ask myself, this would be the cost to jump to this position. And if I do make the jump, then this would be the price, conquer all of these, all the remaining places, cost dot back minus the current thing into B. Yep, this would be the cost. And yep, and if I do not make this jump to this current position, then this would be the cost to get to all of these places. Get to the, yes, this would be the cost to get to the remaining places. And if this cost is higher, then we do make the jump. Mhm. And when we do make the jump, then we increase our cost by the jump price and all of that. And we also change our current position to this castle that we have just conquered. See out, but it just doesn't work somehow. And yeah, it just doesn't work. And I tried Java and show me your approach. What do you think? I just read the question. Java. In no time, I realized I suck at Java, dude. Linus Torvald abuses Java, like literally abuses Java. He says it is the worst language, but it is fine. And I'll be coming with my dad, most probably, if I come. Okay, I'll say thank you or hello to him. And my approach is this. What I'm thinking is if I'm at, these are the places, right? Let's say these are the castle places, and initially I am at zeroth position. Let's call this x0, x1, x2, x3, and so on. And I will have a position, current position, where my capital is. Initially it is 0. And I will be iterating from this thing, from the first castle position forward till the end of the castle. And I know that I have to conquer all of these castles to conquer the last castle. So for whatever the castle I am at first, I will conquer that castle with the position from wherever I am at, right? And that is what I do. Cost equals P into position of the current castle minus my position, the capital of my position, the position of my capital. So initially, since this is 0, for the first case, it is going to be B. Let's actually carry this out for one of the examples, this one. So these are the values. This thing is A, the cost for jumping, this is B. And we have 3, 5, 7, 12, 13, and 21. Initially we are at 0, so initially pos equals 0, pos, and we start iterating from this point. And here our cost will be increased. Our cost would become 3 minus 0 into 7, that is 21. Now we ask ourselves, do I make this jump right now? If I do not make this jump right now, and suppose if I were to go from this position only to all the remaining ones, then the cost, shit, I messed up. Since I made this jump, I messed up a little bit. I messed up a little bit in this implementation. Back minus position. but I made one jump already. So this thing minus the thing that I already added. That shit, I messed up. I messed up a little bit. Okay, so this is the approach. So I ask myself, do I jump to this position? And what is the criteria on which I judge my jumping or not jumping? It is if I were to make jump from this position that I'm at to, if I were to conquer all the remaining positions from this current position, it would be the cost of conquering this, the cost of conquering this, this, and this. And that would be if we add up. Shit, I'm so stupid. Shit. It would be 21 minus x naught. And shit, I'm actually so stupid. Shit. How shit. Okay, and now I'm realizing my mistake. Plus 12 minus x naught plus 7 minus x naught plus 5 minus x naught. And this thing just boils down to prefix sum of this whole thing minus prefix sum of this thing, the current place. Let's call this pref delta interval. This is d, amazing d, into b. That would be the cost if I jump from here, if I conquer every remaining place from here. But if I were to make this jump, the cost, the additional cost I would have to pay would be jmp equals this distance into a into some this distance, which is 3 in this case, 3a. And yes, I am mixing up variables and values, right? I know the value of a, but I'm representing it by a, so bear with it. And if I do make the jump, then I would have to add this to my cost, plus this value would reduce, and this value would reduce. Yes, let's say what the new value would be. New value would be prefix of all of these things, all of these remaining distances. Earlier, I was subtracting from this prefix this value, but now I will be subtracting this value. And if I subtract this whole thing, this would turn out the distance, the difference would turn out to be, let's say the remaining number of elements is n or x. X is the remaining number of elements. I would have, it would not depend on the prefix, it would only depend on the number of elements that are remaining somehow. It literally does not depend on the prefix, it only depends on the number of elements that are remaining. And b, in this case, it would be number of elements, which is x into shit, x into this position, this new position. Let's call it x1 into x. X1 is the position and x is the number of elements that are remaining. Very bad naming scheme. And the other one would be x into x naught. And this whole thing minus jmp, minus jmp, no, plus jmp, plus jmp. And I'm doing a amazing job at explaining all of these things. I put on my laptop and now start. 7 is not there. 7 is not there. Shit. Yes, 7 is not there. Let me try to implement this thing. This part and this part. this would be the new thing and this is the old thing, and we are comparing the new and the old. B into number of remaining elements, x into x1 and plus JMP. I just have to change this internal condition that I have here. If this thing is greater than B into X and pos, then maybe no, then do not do this. Otherwise, do this. Okay, so JMP plus we already have it. What we have to do is instead of back this thing into back, we have to do B into the number of remaining elements, which is n minus 1 minus I, or n minus I, n minus I, n minus I into pos I. And in this case, n minus I, that is the number of elements that are remaining to be conquered. Nope, n minus I minus 1. N minus I minus 1. Because the current element has been, the current place has been conquered. That thing is lower than B into pos. And I just hope it would have worked. GMP, the cost for making this jump, plus this thing, mm, number of elements into pos I and number of elements into pos, the current position. Doesn't work. I'm trying, best of luck. Let's see Java plus C plus plus. Hey, who completes first? Okay. Okay. Let me just go to the washroom and I'll be right back. And I'm not cheating. I'm not cheating. The timer is going on. And I've been sitting here for 3 hours and 23 minutes. I'll be right back. Okay. Just wait a minute. I am totally back. And challenge has been accepted. Let's see. Okay, what is wrong with our approach? C++ versus Java. C++ is better. Hmm. Pos I, B would be the cost, and yes, that is correct. That is so much correct, but it just That is the best place to be at, right? And I think my logic is pretty cool. In this part, the logic is fine. And I'm taking in, yes, I'm taking in all the values, and then cost initially is 0, and position is also initially 0, and I make the jump, and the invariant is that this position is the best position to be at among all the positions that I'm at. Yes, shit, yes, this position is the best one to be at. And yep. Mm, is this literally the best position to be at? I wouldn't know. Shit. I did say challenge accepted. Uh, okay. To put on my thinking hat, my life is on the line. There is a challenge. I have 5, uh, 3, 5, 12, 13, 21, and this is the answer, 173. This is what we want to get at, and currently we are at location 0. We will have to make this jump, and the cost would be 21 to make this jump. Now I need to ask myself, do I jump to this position right now, and is it good or not? Yep, is it good to jump here or not? And if I do not jump here, I'll have to do 5 plus 12 plus 13 plus 21, this whole thing, jump from 7, for jumping 7. And if I do make the jump though, I will have 6 plus the distances would be counted from this point, and it would be 2 plus 7 plus 8 plus not 14 plus 18, 8 and 18, wait, I messed up in that part, 9. This is not 7, this is 7, this is not even close to 7, this is 9, 9 and 10, 9, 10, 18 into 7, that would be the cost if I do make the jump. So if I were to actually calculate this thing, it would be 5, 3, 10, 11, 1, 5 into 7, it would be 357, 357, and here the cost would be 7 plus 10, 39 into 7, 39 into 7, which would be 6 plus 7 into 39. What is that? 240 minus 7 to 33, and this would be 239. So it is cool to make a jump right now, and I think the logic is correct, but the way that I'm checking this condition, that is absolutely horrible. Okay, so at on one side we have cost of jumping to this current position, and that I am calculating correctly, at least I believe so. A into the difference in the current position minus the position that I was at, that is the jumping cost. Add that to this thing. What is this thing? This thing would be b into the cost of jumping to all the rest of the places. Uh, this, this, and this. Sum of all of these minus this thing into the number of things here. That is, we could say the prefix of this whole, let's say the sum of this whole thing is x. So x minus, and there are, let's say, n of these things. N into, we are currently at ai, xn into ai, even though we are using a for something else. Let's call this pi, as in position I. This would be the cost if I do make the jump. If I do not make the jump, then the cost from jumping from this place would be minus n cos the current position. That would be the cost then. And if I want to compare these two things, I could say that I subtract minus bx from both the sides. Minus bx from both the sides. If I do that, here minus bx would be gone. Here minus bx would be gone. And therefore, this should be negative sign, not positive. Wait, the sign here should be negative. Uh, yep, we are seeing if this thing, if this thing is smaller. If this thing is smaller, then do make the jump. Wrong answer on one case, which is this one. And I'm getting a higher cost than actually what is actually the cost. Is it because of some subtleties? Let's keep this an integer. And here long, let's say one is long, one is long, and here b is an integer, and this distance is also an integer. Yeah. Okay, shit. Okay. C++, Java, C++ versus Java. Shit, maybe I got this. At the best position be at, you can jump without conquering. Yes, I am first conquering. This problem is so confused. I'm getting how to approach this. No. Maybe I got this. Maybe I did got this. Shit. C++ will win. C++. Bjorn Stroustrup wins. Why am I changing the compiler? Okay, if I get this right, I would be happy. And okay, okay. I might be a happy man today. I might go to sleep as a happy man today. Shit, shit, shit. I might get to eat Parle-G today. Okay, this is working. That is actually correct. That is actually correct. Shit. Genius level IQ. It took me 1 hour and 15 minutes to do this singular question. I can write this here. 1 hour, 15 minutes. I got this. I got this. Oh, congrats. Let's go. Yo, we won. We win these. We win these. Shit. Yep. Yeah, that is cool. That is cool. That is cool. Got it right. Shit. Okay. Now, like good programmers, what you have to do is I started like 5 minutes back. Let's see how long. Okay. Okay. Yes, you have a buffer of 1 hour and 10 minutes to do the question. And let's guess what the tags are going to be. I would say greedy algorithm and yeah, greedy algorithm and number theory, something like that, maths. Okay, greedy is it? How can someone apply binary search here? how would I even solve a question without implementation? And why do you have greedy and DP in the same category? Okay, now we're moving on to reading the editorial. Maybe you would not like to watch the stream now since I'm reading the editorial. You'd get a bit of spoiler alert. Shit, there is a hint, and the hint is that there are three hints. Try to analyze the cost of each operation separately. Is there some linearity? Huh, linearity you can exploit. Try to make greedy decisions. Can we say that it is always better to move right whenever possible? Nope, it is not always better. Let's say you fix the final position of your capital. Now think about hint 2. If I fix the final position of my capital, then think about this. Think about uh, think about this. If I have fixed the final position of my capital, then what would it be? If I fixed the final position of my capital, let's say here, then what would be the parameter on which I judge this? Go there. From that would mean jumping from this place to all of these as gives the minimum cost, but I could just say my final position is the last position. That would be the best position to be at because it is already conquered. Let's see. And before actually reading the solution, I would like to just sanity check, delete and write the solution again. Yep, not just N, there were A and B also, N, A and B, seen N, N, A, B. And then we have a vector to work with of integers. It will be called pos position, and the size would be n, and for end reference x in pos c in x. And what is that? For end reference x in pos taken x, cost long cost is long cost initially is 0, and after cost being equal to 0, what do we do? When cost is, yes, pos c, let's say current position is represented by c, and now I have to start iterating for int I equals 0, I less than n, I plus plus, and I will jump to this place, and cost would become cost plus equals the cost of getting here is b into long and that thing. Let's make this thing long c so that we are cool, and b into the current position pi minus c, that is the cost. And what is the cost of jumping? The cost of jumping is a into cos I minus c, that is the cost of jumping. And if jump minus that thing b into n minus 1 minus the n minus 1 minus cos I n minus 1 minus I, that is the remaining number of elements, into cos I, if that thing is lower than b into negative b into n minus 1 minus I into the current position of the capital. If that is the case, then c equals cos I We have jumped to this place. Yep. Go to position I and and also yep, and also other than this, uh, update the cost plus equals jump, the cost on jumping. See out cost. Okay, I messed up at some place and probably because of some long thing. Okay, now it is correct. And let me just resubmit this thing. Sanity check. Uh, yeah, close your eyes. Close your eyes. Don't look at this. Okay, it is right. It is correct. It is working. And a lot of maths. A lot of maths. Minimum. Okay. Clearly, we should always move from left to right. Okay. Clearly, yes, because it would be reducing cost for everything. And yes, because it would be reducing cost for conquering, but it would only increase the cost for jumping. That would be the only thing added. Assume x0 equals 0 for simplicity. Okay, let's go simple. Let us analyze what our cost would look like. It would be composed of a part due to moving capitals and a part due to conquering kingdoms. If we shift our capital from this place to this place, the cost would be a into this thing. If we conquer kingdoms from this to this and j is included from the ith place with capital Xi, the cost would be b into the sum of this whole thing, and which can be written as pj minus pi, where p, j and pi are prefix sums. This would be the sum of the thing in the middle, and from this we are subtracting xi minus xi into the number of elements that there are in the middle. Subtract that. Notice that this thing j minus xj minus xi and this are linear. What do you mean linear? Also, if we isolate the parts involving this, uh, the sum will be like this, which is xjf jump. If we isolate the parts f, jf, what is jf? J1 j2 j3, what the heck are j1 j2 j3? Also, if we isolate the parts involving these, the sum would be like this. This means we can simply write the final sum of this part as a into f xf xf. Okay, and what is f? What is f? Where xf is the final position of the capital. We can say the same thing about this. I don't know why, but this is not making a lot of sense. Maybe because I have been streaming for too long, and also I'm hungry, and that is why I guess this is not making sense. And also my camera is broken. I guess that is why this doesn't make any sense right now. Not right now. So even though I did the question right here, I got this right. The editorial is not making a lot of sense. And when you're hungry, eat Snickers. And I guess for today, this would be the end of the stream. Hello, shit. Yep, I would have to go because this has been too long and I want to eat because eating seems like from like I've been alive for some time, and I have discovered that if you do not eat, you will die. So I guess I will have to eat. The approach I'm thinking of is brute forcing. I have muted because you leak shit. Because leak shit. Okay, thank you. Thank you. Bye bye. And brute force, brute force. Yeah, brute force. Okay, thank you. Bye, and thank you for being here.